Okay, so today we're going to be talking about the triangle midsegment theorem. This is 6.4, excuse me, in your textbook, and we are on page 26 of our packet. So we can see that a midsegment of a triangle is a segment that connects the midpoints of two sides of the triangle. So we're going to do a little bit of an investigation using the distance formula and slopes to discover what's going on with this midsegment and some properties about it. So we have this triangle ABC has coordinates A is 6, 8, B is 10, 12, and C is 14, 6. And they're telling us D is the midpoint of AB, E is the midpoint of BC, and DE is the midsegment of the triangle because, by definition, a midsegment is a segment that connects the midpoints of the two sides. So we're given that D is the midpoint of AB, making A and B congruent, D being the midpoint. E is the midpoint of BC, making BE and EC congruent. E is the midpoint, and DE is the midsegment because it's connecting the midpoints of the two sides. So we want to find the coordinates of D and E, so that means we want to find the midpoint of AB. So to jog your memory, midpoint formula is the average of your x's and the average of your y's. So if I find the midpoint of AB, I have 6 plus 10 divided by 2 and 8 plus 12 divided by 2. I get 16 divided by 2. 16 divided by 2, 16 is 8, divided by 2 is 8, sorry, excuse me. And then 8 plus 12 divided by 2 is going to give us 10. So D has a point, the coordinate for D is 8, 10. And then I'm going to do the same thing. I have some space over here, but for BC to find the midpoint, the coordinate of E. So I have 10 plus 14 divided by 2. Running out of space here, 1 second. And then I have 12 plus 6 divided by 2. And that's going to give me the midpoint of BC, which is point E. 24 divided by 2 is 12, and 18 divided by 2 is 9. Okay, so we get that E is 12, 9. All right, so now looking at the next step, we want to find the lengths of DE and AC. So we want to find the distance, just again to jog your memory. Distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So first I want to find the distance of DE, excuse me. So DE, I'm going to label this x1, y1, x2, y2. So I have a long square root of 12 minus 8 squared plus 9 minus 10 squared. I end up with negative 4 in parentheses squared plus negative 1 in parentheses squared. That's going to give me positive 16 and positive 1, because negative times a negative 4, negative 4 times negative 4 is positive 16, negative 1 times negative 1 is positive 1. So I get root 16 plus 1, which gives me root 17, and that does not simplify. So there's the distance of DE. Now I'm going to do the same thing and find the distance of AC. Okay, so I like to label my points here. Let's label this x1, y1, x2, y2. So I have 14 minus 6. Oops, sorry. 14 minus 6 squared plus 6 minus 8 squared. And I end up with 8 squared plus negative 2 in parentheses squared, which ends up being 64 plus negative 2 times negative 2 is positive 4. So the distance of AC is 68, which simplifies to 2 root 17. This is the square root of 68. which simplifies to 2 root 17. Okay, and in case you wanted to see that, the perfect square here, right, like root 68, that breaks into root 4, root 17. That's how I'm getting that 2, because the square root of 4 is 2. So that, anyway, that's how that simplifies. Finally, we're asked to find the slope of DE and AC. So again, I'll do it over here on the side. Slope formula. Lots of formulas you need memorized here. Slope formula is the change in y over the change in x. So when I look at the slope of DE, I have these labeled here. I'm going to do 9 minus 10 in my numerator, divided by 12 minus 8. 9 minus 10 is -1, 12 minus 8 is 4, so I get the slope of DE is -1/4. Now I'm asked to find the slope of AC. So again, I had those labeled. I have 6 minus 8 divided by 14 minus 6. So I get -2 over 8, which ends up simplifying as well to -1/4. Okay, so let's take a look now what's going on, right? So we're seeing that this mid-segment, that had a distance of root 17, and the other side, the side, the third side, not connecting, right, like this mid-segment DE is connected to side AB through D and BC through E. So the third side, the non-connected side, we can actually see if this is root 17, what's the relationship between the mid-segment, this distance, and that third side? We can actually see that the mid-segment is half of the third side, half the length of the third side. And then if we look at their slopes, we can see that the mid-segment, the slope of the mid-segment is -1/4, and the slope of the third side is also -1/4. So what relationship does the slope of the mid-segment have to the third side? It is in fact parallel. So that brings us to our triangle mid-segment theorem, which is the segment connecting the midpoint of two sides of a triangle is parallel to the third side, and it is the length, and its length is half the length of the third side. And we can see that here. If DE is 17 and AC is 2 root 17, DE is half of AC. And their slopes are both -1/4. Okay, so now, right, this is just one mid-segment of the triangle because it's connecting sides AB and EC. But if we were to find the midpoint, I'm going to call this F. If we were to find the midpoint of the third side, I could then create another mid-segment, EF, which would be going through sides BC and AC. It would be half the length of BA, parallel to BA. And then I could also look at this mid-segment, DF, which would be connecting sides BA and AC. DF would be half the length of BC and parallel to BC. So by kind of sketching that out, you can see there are three mid-segments of a triangle, which is what we're looking at in the next section. So let's go ahead and draw the other two. That's kind of what I was doing above. So we'll eyeball this. Let's call this F. By the way, D bisects BA, E bisects BC, F would bisect AC. So EF is the mid-segment connecting, like I said before, BC and AC. And then DF is the mid-segment connecting side AB and AC. So now they're telling us that the entire length of AB is 20, the entire length of AC is 24, and the entire length of BC is 28. So using the fact that the mid-segments go through the midpoint of each side, go ahead and find the missing lengths here. Find AD, DB, BE, EC, AF, and FC, and see if that can help you find the lengths of the midsegment. So let me pause that. You can go ahead and start finding those lengths, and then we'll regroup. Okay, so hopefully you were able to find these individual pieces. Now we want to find the lengths of the midsegments, but let's go back to our theorem. If we're looking for the lengths, the midsegment is half the length of the third side. So for example, DE, this midsegment, the third side we're talking about is 24. Half of 24 would make DE 12. Using that reasoning, see if you can find EF and DF. Okay, so using that reasoning, we can see that EF is 10 because it's half of AB, which is 20, and DF is 14 because it's half the length of the third side, BC, which is 28. So we're seeing here that the midsegment triangle is the triangle formed by the three midsegments. So this is the midsegment triangle. It's formed by the three midsegments. Given the side lengths of triangle ABC, we were able to find the lengths of the midsegment. Okay, so moving on here to our theorem about the midsegment triangle, we can see that the midsegments of the triangles create four congruent triangles. And if we kind of look back here, right, we can see if I, right, like 12 here is 3 tick marks, 14 was 2 tick marks, 10 was 1 tick mark. So I can see I have side, 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 side. Oh wait, I'm sorry, you can't see. Let me try again. So triangle, this triangle on top is congruent through side, 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 side. This middle midsegment triangle, this triangle down here, ECF, side, 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 and again, this triangle over here, side, side, side. So it's creating four congruent triangles. That's what we wanted to put in as our theorem here. So the midsegment triangle creates four congruent triangles. So now we can use this information about our midsegments and our congruent triangles to help us find missing pieces in this example. So we're given that AB is 22, BC is 18, and AC is 25. And we're trying to find X, which is the midsegment to side BC, Y, which is the midsegment to the third side AB, and Z, which is the midsegment to the third side AC. Go ahead and try that one, and then we'll regroup. Okay, so here I'm showing like all the work for our notes, right? Showing that the midsegment is half its third side. But most of you, I think, were able to probably do this without showing much work. I'm just leaving this for the purpose of the note so you can see. You should have gotten that X is half of 18, which is 9. Y is half of 22, which is 11. And Z is half of 25, which you could leave as an improper fraction or a decimal. Okay, so what we're doing for the next one here, and I'll kind of use the same setup where I pause and you kind of do the work on your own and then continue with the video to check your work. So in exercises 1 through 4, we're using graph of triangle ABC. The first thing we want to do is find the coordinates of midpoint D, which is the midpoint of side AB, midpoint E, which is the midpoint of side CB, and midpoint F, which is the midpoint of AC. So kind of like what we did in the front. Go ahead and pause and do your work, and then we'll regroup. Okay, so go ahead and check your work. You should have gotten the midpoint of AB, which is D, is -2, 2. E, the midpoint of BC, is -1, 2. And F, the midpoint of AC, is -4, 1. So you want to then graph the midsegment to form triangle DEF. Okay, so now we want to show that DF is parallel to CB, FE is parallel to AB, and DE is parallel to AC. So we're going to do that next. That's step 3. So you're just verifying that the midsegment is in fact parallel to the third side. And then after that, you want to show that the midsegment, for example, DF, is half the length of BC. So you're using the distance formulas here for DF and BC, again for FE and AB, and then again for D, E, and AC, just like we did on the front. So I'm actually going to stop the video there. I'll post the answers on Google Classroom so that you can check your work to the classwork. And then once you're done with that and you've checked and you've gotten it all correct and you feel confident, you can move on to starting the homework in class.